This is a CIA past paper 1 question from year February March 2018. So here the question states that express the equation 5 plus 2 tan x by 3 plus 2 tan x equals to 1 plus tan x as a quadratic function in tan x, and hence solve the equation for x between 0 and pi. That means x is between 0 and 180 degree. So let's start now. So here we can see 5 plus 2 tan x over 3 plus 2 tan x equals to 1 plus tan x, and then we first express this in terms of quadratic equation, and then we solve that quadratic equation for tan x and hence x. So by cross multiplication you can see that this is 5 plus 2 tan x equals to 1 plus tan x, and then when you transpose this towards right, it's going to be multiplied over here. So this is 3 plus 2 tan x, and then you simplify it, so it is 5 plus 2 tan x equals to 1 times 3, and then this is 3. If you multiply these two, open the bracket, so this is 3 plus 2 tan x, and then you multiply by tan x, applying the distributive law here. So it is tan x means 3 times of tan x, and then plus 2 times of tan x times tan x is tan square x, and then you can see from both sides these two terms have been cancelled out, 2 tan x, and you are left with here 5 equals to 3 plus 3 tan x plus 2 tan square x. Now rearrange it. Now first solve it and rearrange, so that you will have 2 tan square x plus 3 tan x. Then it is, you can, if you transpose this to the right, and then it is 3 minus 5 is minus 2 equals to 0. Now you can see that this is a quadratic equation in tan x, where in place of x square we can see here it is tan x square, and therefore you can apply the formula for the quadratic equation, that x equal to minus b plus minus under root b square minus 4ac by 2a, or you can factorize it to find the value of x. But these are, although these are also a good idea, but better idea is that use the calculator and get the value of tan. So in the calculator, under the mode function 3 5, you can see here that we have got from calculator it is tan x equals to 1 by 2, and then another value of tan x from the calculator, where you suppose tan x as x, so that it will be in form of in the form of 2x squared plus 3x minus 2. So this is tan x, another value is negative 2. Now what does the question say here? That express this sort of equation as a quadratic equation. So we have already expressed this, so one of the answers is here, and hence solve the equation for x between 0 and pi inclusive. So now this is the turn to solve it. So first of all you got the value of tan x, now we'll get the value of x from this. So again, by using calculator, you can use calculator either in degree mode or in radian mode. Both will work here, but what I'm going to take is that as you can see here that x is given in terms of pi, that means this is pi radian, so we keep the calculator in radian mode. So once you keep the calculator in radian mode, then you'll see that value of x is for tan inverse 1 by 2, and then another value of x will be tan inverse of -2, and then from calculator you can see that if you press shift and tan then half, then your value is going to be 0.464. This is 0.64464. all right, so this is in radian, and then from the calculator again the value of x for tan inverse -2, that is going to be -1.107. You can also express that in terms of two significant decimal, but as the radian is measured the entirely in within 2 times of pi, so it is good idea to take at least up to take the value of angle at least up to 3 decimal places, or even if you take up to 2 decimal places it would be okay. Now you can see that x should be in between 0 and pi, and you can see that x value is negative here, so we just ignore this value. Okay, now you work for this. So first value that we have obtained is called the principal value. So this is principal value, that is one of the answer only, and you can also say this as the principal value, but we don't need this because x should be between 0 to pi inclusive. And now we shall try for another answer. So let's take a reference of a tan graph simply, although you don't need to draw the graph over here, but if you draw the graph it will be a good idea. So let's now take here that one line of reference as it is 0, and then you know that graph of tan shows asymptotic nature about theta equal to pi by 2, and here in this case x equals to pi by 2, so this is y-axis and this is x-axis over here, and then we work up to pi because it has said that to get the solution up to pi, so we work up to only pi from 0 to pi, and then in that case we can say that at 0 degree of tan, this is a tan graph I am talking of, graph of y equals to tan x. Alright, so here if you talk y equal to tan x means then at 0 it is 0, and then after that if you increase the value of angle, the tan value will start increasing and it goes near and near to when x equals to pi by 2 in this case, then it shows the asymptotic nature. That means it doesn't touch this line x equals to pi by 2, and hence it shows asymptotic nature about this sort of line, and pi must be somewhere here now, and you know that at pi the value of tan is 0 again. Right side we don't require it, but left side when you come near to this line x equals to pi by 2, then again it will show asymptotic nature about this towards negative infinity side, and it is towards positive infinity side. Alright, so this section of tan graph we are taking here, but we are interested to find the solution for this. You can see that here from here, like we are only considering this equation tan x equals to half. That means there are two facts. You can say one of the y is tan x and another of the y is, we can say y2 equals to half. That means you can say here that tan x equals to half. That means there are two lines in fact, and equal to these two lines are when equal, then they intersect at some point, so that here we have this is the graph of tan x between 0 to pi inclusive. But here again you can see that another line is half, so that the point of intersection between this line y equals to half, you can say here this is y equals to half, and this curve is at some point over here, and from this you can see that the first intersecting point is in fact the principal value, and this value we have found as 0 point, this is 0 0.6 0.464. Alright, now we work out for other values of other solutions of this sort of equation within 0 to within pi. Even though we have neglected this value of x as x equals to minus 1.107 radian, but it will be useful in finding the another solution for x, because you can see that this up to here, this is pi we have, and x is supposed to be in between 0 and pi. So in that case there is possibility that there will be another one solution as well, and then we have to find another point of intersection by taking one equation as y equals to tan x and another as y equals to -2, and these two lines, and if these two functions are equal, that means there is a point of intersection between these two sections, and then probably your line will also be like that, where it is y equals to -2. And in order to do that, although the negative value of x has been neglected over here because of the given domain of this function, and then what you can do, actually we can just consider as a reference that some other point about here, you draw a line about here, and you can say this line as -2/3, sorry, -pi/2, and then let's go up to -pi over here. So your another line will be like this, okay, where -2 pass through, this passes through, and then this point is -pi, and if you extend this graph up till here, then your graph again when reaches the line x equals to -pi/2, it shows the asymptotic nature like this. And then you can say that at this point at x equals to -pi, this is again 0, but when it is nearing to this line x equals to -pi/2, it will show the asymptotic nature about this line. And then this value, you can see that pi is here, it is somewhere here, and then another value pi/2 is here, and then if you check the calculator, then you can see that pi divided by 2 is something like 1.57. so -pi/2 is itself 1.57 nearly equals to, then this point x equals to -1.107 must be here inside that -pi/2, and that will be given by the point of intersection between tan x, y equal to tan x, and y equal to -2, that is y equals to, this line is -2, y equals to, this is y equals to -2, okay, and so this value is known to be -1.107 nearby radian. And now this line intersects the curve again at this point, and you can see that this point has been raised after you add about this point 180 degree. That means your another value of x at this point is going to be x equals to -1.107 and plus pi. Okay, so let's take a calculator, and in the calculator we can put -1.107 and plus pi, and then that is going to be equals to 2.035 radian. So this point is going to be 2.035 radian. So therefore you can say the solution for this sort of equation is now one possible value of x is, you can see here, 0.464 radian, and another possible value where we get the solution for this equation is 2.035 radian, and these are the answers. Now in the same question to the part B, you can see that this is a given curve, and let's see what question says about this. So it says that the diagram shows part of the graph of y equals to k sine theta plus alpha, where k and alpha are constants, and alpha is between 0 degrees and 180 degrees. Find the value of alpha and the value of k. In that case, you have to analyze this graph actually. So along the x-axis, you see that along the x-axis theta has been plotted, and along the y-axis y equals to k sine theta plus alpha is plotted, and by this condition you have to find the value of alpha as well as the value of k. So in order to find the value of alpha, you have to check at some point here that when theta equals to 0 degrees, y is going to be 0. And here when theta is 0 degree, y is going to be 2. So we'll use these two facts, and then we'll check whether or not we are up to the solution. So first start with this point. So where theta is 150 degree and y is 0, then what you can write here, 0 equals to k times of sine 150 plus theta, and then you'll have after that sine 150, this is not theta, I think alpha, yes, 150 plus alpha. When you transpose k to the left over here, then you will have here 0, and you know that sine inverse 0 is 0. So you can see here one of the value as yes, one of the value of 150 plus alpha equals to 0, it gives you alpha equals to negative 150 degrees, but your question said that alpha should be in between 0 to 180 degree. Then we'll try for some other value of sine angle of this, where sine is 0. So another value of where it is 0 is 150 plus alpha, you can write that is equals to 180 degrees, or you can just transpose this towards right, you can say sine inverse of 0, and that occurs at also 180 degree, and therefore alpha in this case we found as 30 degree. Okay, so one of this constant value we have already found it. Now we shall use this point 2 where you can see and this equation, and so here you can see that y value is 2 equals to k, and then theta value we have already got, no, theta value, yes, it is 0 over here. So first of all let's write it is sine, and then theta value is 0, but alpha value that we have got is, it is 30 degrees. So in fact it is going to be equals to 2 equals to k sine 30 degrees, and you know that sine 30 degrees value is, this is k times 1 by 2, so sine 30 degrees is 1 by 2, and therefore k equals to 2. When you make cross multiplication from both sides, then it will be 2 times 2, and then that is equals to 4. So therefore in this case your value of alpha is 30 degrees and the value of k is 4, and this is the answer. Alright, so in this way, before you start to solve the problem, first of all read it properly and try to understand what the question is, what the question has given and what it is asking you to find. And once we have all these things clear, then analyze the figure or analyze the given data in order to reach to the correct solutions. Okay, so that's all for now.